In this question, you have been asked to find out the ratio of solubility of silver chloride in 0.1 molar potassium chloride solution to that of water. First of all, let's compare their solubility in water and potassium chloride. Silver chloride is a sparingly soluble salt and they will produce Ag plus and Cl minus ions in both the solutions. If you are considering 0.1 molar potassium chloride, they can also produce 0.1 molar potassium ions and 0.1 molar Cl minus ions. Solubility product can be written as it is the product of molar concentrations of the cations and anions produced from the sparingly soluble salt in the solution. Now, here the solubility of Ag plus ions or the concentration of Ag plus ion will be small letter s and that of Cl minus will be s plus 0.1 because the Cl minus ions are not only produced from AgCl, it is also producing from 0.1 molar potassium chloride in the first case. Hence, the total concentration of Cl minus ion will be the concentration of Cl minus from AgCl plus the concentration of Cl minus from potassium chloride. Now we can write the expression for solubility product by multiplying the concentrations of Ag plus and Cl minus ion. So that is concentration of S into concentration of S plus 0.1. The final answer will be 10 raised to minus 9 molar because the solubility product of silver chloride is given here, that is 10 raised to minus 10. Now let's see the solubility product in water, that is the second case. Water doesn't produce any Ag plus or Cl minus ions. So here the concentration of Ag plus and Cl minus ions will be same, that is equal to small letter s. Now we can find out the solubility product by multiplying the concentration values, that is S square. Now we can see the solubility that is equal to 10 raised to minus 5 molar. If we are taking the ratio between the solubility of AgCl in potassium chloride and water, it will be equal to 10 raised to minus 4 is to 1. So from these options we can see the correct answer is option A.